Ever wondered how muddy water gets clean or how seawater becomes something you can actually drink? The answer starts with understanding mixtures, and today we're breaking down exactly what they are. A mixture is simply two or more substances that are physically combined but not chemically joined together. That's different from a compound, where atoms bond together and form something completely new. In a mixture, each substance keeps its own properties, even when it's stirred right in. Salt water, air, and even a bowl of cereal with milk are all everyday mixtures. Because nothing new is chemically formed, mixtures can be separated back into their original parts. Scientists use different separating techniques depending on what the mixture actually contains. Let's start with filtration, which separates an insoluble solid from a liquid. Insoluble just means the solid won't dissolve, like sand sitting in water. You pour the mixture through filter paper and the tiny holes let only the liquid pass. The solid gets trapped behind, called the residue, while the liquid that passes through is the filtrate. Next up is evaporation, perfect for separating a soluble solid like salt from a liquid. You gently heat the salt water, and the water turns to vapor and escapes into the air. Left behind are pure, dry salt crystals sitting in the bottom of the dish. The downside is that we lose the water completely. It just vanishes as vapor. But what if you actually want to keep both the salt and the water? That's where distillation comes in, a clever method that collects the liquid too. You heat the mixture so the water evaporates just like before. But this time, the vapor travels through a cooled tube called a condenser. As it cools down, the vapor turns back into liquid and drips into a fresh container. This gives you pure water, completely separated from the salt left behind in the flask. So filtration, evaporation, and distillation each solve a slightly different separating problem in chemistry. Next time, we'll explore chromatography, a brilliant technique for separating colors and dyes.